All right, ladies and gentlemen, we are talking lesson 2-9. It's Wednesday. I will be in DC, even though I'm recording this on Sunday night just before I head off to bed. I'm going to be getting up bright and early for this event. Uh, we're talking about exponents, and it's really important for us to know why we would use exponents. So that's our essential question of the day. So make sure you get that stuff written down into your notes. Again, if you need to pause any point in time, hit pause. I'm going to go through the definition things here quickly so that you can go ahead and write them down in your own time here. So exponents, what are they and how are they used? Exponents are just a way for us to write larger numbers or smaller numbers in a short fashion. So over here you can see that we have the base of a number, and then this guy up here is called the exponent, or it's called the index, or it's called the power. If I see an x to the second power, you might hear me say x squared. If I see an 8 to the second power, or an 8 to the third power, you might hear me use the words cubed. So a base is the common factor that is going to be multiplied over and over and over again, or being raised to that power. So what does it really mean to have an exponent or a 6 to the fourth power? So we're going to talk about how do we write these things as longer math problems. So 6 to the fourth power, as you guys remember from last year, just means I have 6 times 6 times 6 times 6. So there's 4 sixes, which means then 4 to the third power is 4 times 4 times 4. And hopefully everybody knows that anything to the 0 power equals 1. So 2 to the 0 power equals 1. 100 to the 0 power equals 1. And that's important for us to make sure that we know in case you come across a problem like that. And I'll show you on the next slide as to why that is. So an example for us is to change this long expression into exponential form. So I have 1, 2, 3 5s, which means it's 5 to the third power. I have 1, 2, 3, 4 3s, which means it's 3 to the fourth power. Now notice that I have a multiplication sign in between them, because if we multiply these numbers all together, we're going to have to multiply my common bases to the exponent together as well. So on the next example, when I have 1/3 times 1/3 times 1/3, that means, oopsies, I just made my pen jump. We'll get rid of that. That means that I have 1/3, and I'm going to put it in parentheses so that we know that the whole thing is going to be to the third power. And I have 2 7s, so I'm going to multiply that by 7 to the second power. Now, those should seem fairly simple, and I'm hoping you guys understand that as well. Now, 2/3 to the fourth power means 2/3 times 2/3 times 2/3 times 2/3. Or if you write this in another way, we could say it's 2 to the fourth power over 3 to the fourth power. And then I could do the math here. 2 to the fourth power, see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so my numerator is 16. 3 times 3 is 9, and there's another 3 times 3 is 9, so that becomes an 81. So that would be us simplifying, and then we would reduce if we could. So you guys can see the pattern there, of course, hopefully. If I have any fraction to a power, both the numerator and the denominator get that same power, just like we showed over here. All right, now sometimes we have negative exponents, and let's go through just a little quick chart for you. If I have 2 to the first power, that means I'm going to say the exponent, and then this is the value. We'll just make a quick chart here. 2 to the first power makes a 2. 2 to the second power makes a 4. 2 to the third power makes an 8. Notice how we did 2 to turn into 4, we did times 1 more 2, times 1 more 2. So if I get smaller, 8 to turn into a 4, we had to divide by 2. 4 to turn into, we had to divide by 2. So if 2 to the 0 power has to be then a 1 because we divided by that 2. So if I have a 2 to the negative first, now I have a divide 1 by 2, which is 1 over 2 to the first. If I have a 2 to the negative second, that means I have 1 over 2 to the second, or, which is down here, 1/4. So because our pattern was to, going from right to left, was to divide by whatever our base was, we're going to have fractions when we get into negative exponents. So what that does is that changes this exponent from being negative, it brings it to the bottom of the number and to the denominator and changes it to be positive. So quick example here, if I have a 3 to the negative 7th power, that negative 7, because this is over a 1 right now, that negative 7, the whole thing here I guess, is going to go to the bottom. So the base and the exponent come to the bottom and then they change to be positive. So it's 1 over 3 to the 7th. And then we would of course figure out whatever 3 to the 7th is. I'm going to have to do that on my phone because I don't have a calculator at my house because for some reason I wasn't that prepared for this. Don't tell my wife. So 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5 times 3 times 3. 1, 2, 3, 4, 5, 6, 7 of them. So I get the answer of 1 over 2,187. Now, and this is the type of work that I would expect to see in your guys' assignment then too. That you would show me how it changes from a negative exponent to a positive exponent by bringing it to the bottom side of the fraction. Okay, so let's try this 5 to the negative 4th. Hopefully you'll have a 5 to the negative 4th written down as a 1 over 5 to the positive 4th. And 5 times 5 is 25. And since there's 2 more of those, 25 times 25 is 625. Double check. Yes, I'm correct. So that becomes 1 over 625. Now I got one more thing I want to show you because I'm done with examples after this. And this is a just for fun. I'm not sure if we'll have an assignment that looks like, or a problem in your assignment looks like this. If I have a 1 over 2 to the negative third, just like up here, the negative switched to the bottom. On this type of a problem, to get rid of a negative exponent, we bring it to the top. So if the negative exponent's on the bottom, we bring it to the top to make it positive. By switching over this division line, the fraction bar, it changes the exponent to be positive. So this would be equal to 2 to the third power, which is an 8. So that's the stuff we got to be able to do with the exponents, folks. Hopefully you're having a good time with me being gone and you're learning all the things you need to learn. We'll discuss how this whole video thing worked out for you guys when I return on Monday the 20th. Alright, here is your assignment. Make sure you get it done. Show all your work. Enjoy your MEA break. See you, folks.